Okay. So we talked about we can draw a triangle in the units, well, the unit circle itself. The center is at the origin, the coordinates 0, 0, and the radius is 1. And we can draw triangles inside the unit circle where the right triangles where the hypotenuse is 1. And we saw that we were able to draw right triangles in any quadrant. Okay. And then we were able to find corresponding points on the unit circle depending on the angle that we used. So this is what it looks like. So here's a right triangle in quadrant 1. Okay. I mean, we could have done it. We could have drawn one in quadrant 3. Like so. Remember how to draw a right triangle on a coordinate grid, we never use the y-axis as a side of the right triangle. One side of the right triangle is always on the x-axis. The hypotenuse always comes out from the middle, and then the third side is vertical that connects the two. So in this case, we'd have 1 again, but this time we'd have negative x and negative y. Or we could draw a right triangle in quadrant 4, or we could draw a right triangle in quadrant 2. Okay? No matter where we draw the right triangle. And we'll focus on this one. Well, so here's our angle theta, right? It's the angle that comes out from the center. What's the ratio to find cosine of any angle? What side over what side? Adjacent over hypotenuse. In this right triangle that I've drawn here and labeled x, y, 1, what side is the adjacent? And what side is the hypotenuse?
1.
Which means that the cosine of the angle coming out from here will be whatever the x value is of the point on the unit circle over 1, or just plain x. Similarly, sine is opposite over hypotenuse. But in this right triangle, it's what side over what side? Y over 1. Which is just the same as the y coordinate of the point on the unit circle. And tan, opposite over adjacent. But in this right triangle here, it would be y over x. Well, we got to calculate that. So that means that if I give you any angle that's on the unit circle, so like 30 degrees, 45 degrees, 60 degrees, 90 degrees, 135 degrees, 210 degrees, all those angles that we did on the unit circle in the last lesson, you can tell me the cosine, sine, and tan without using a calculator. So for example, if I say, I'm going to tell you that this is 45 degrees. If this is 45 degrees, do you remember what this point is on the unit circle? Look at your unit circle if you need to. Root 2 over 2, comma root 2 over 2. So, what's the cosine of 45 degrees? Well, it's whatever the x coordinate is over 1, which is just the x coordinate. So the cosine of 45 is root 2 over 2. It's just the x-coordinate. What's the sine of 45? It's the y-coordinate of the corresponding point on the unit circle, which is also root 2 over 2. What's the tan of 45? Well, this we have to do some calculation. It's the y-coordinate, root 2 over 2, divided by the x-coordinate, root 2 over 2. Well, what's root 2 over 2 divide root 2 over 2? What's anything divide itself? 1. And if you do that on your calculator right now, the tan of 45 degrees, you'll get 1. But now you can find it without a calculator. Okay? You can find the exact values. If you did the cosine of 45 degrees on your calculator, you get some decimal answer. But if you did this divide this, you get the same decimal answer. So now we can find trig ratios of certain angles, the ones that we talked about on the unit circle. Okay? So depending on the angle and its corresponding point on the unit circle, the cosine of that angle will always be the x-coordinate. The sine of that angle will always be whatever the y-coordinate is. And the tan of that angle, like I said, we have to do some calculation. We have to take the y-coordinate divide the x-coordinate. So let's look at some examples. Let's say you were asked to find the sine of 150 degrees. Okay? What you need to ask yourself is, because it's sine, what is the y-coordinate of the point on the unit circle that corresponds to 150 degrees. Where is 150 degrees? It's the one that's down here. That's where we have negative root 3 over 2, the long side, and positive 1/2. Well, what's the y-coordinate? That's your answer. You're done. That's it. We actually just did this one. So again, I'm asking myself, what's the y-coordinate, because it's sine, of the point on the unit circle where the angle is 45 degrees? It's root 2 over 2. What's the cosine of 150 degrees? Negative root 3 over 2. Now we got a different name. 240. Where is 240 on the unit circle? Well, it's in quadrant 3. That's 210. That's 225. 240 is the one down here. What's this point? What's this? No? Look at your unit circle now. 240 degrees. Right. So what does that mean to find the tan? We have to take the y, divide the x. So we have to go negative root 3 over 2 divided by negative 1/2. So we have to remember how to divide fractions. How do we divide fractions? Change it to a multiplication. Negative root 3 over 2 times the reciprocal of negative 1/2. Which is negative 2 over 1. Well, times 2, divide 2, cancel each other out. So I'm left with negative root 3 over negative 1. And the simplest way to say that is positive root 3. So cos, read the x-coordinate. Sine, read the y-coordinate. Tan, divide the y-coordinate by the x-coordinate. Few more. Use your unit circle if you need to. Okay? But again, you should be starting to remember the points on the unit circle rather than having to reference it all the time. So again, I look at sine 330. Sine means y. What's the y coordinate at 330 degrees? 1/2? Negative 1/2. Cosine, what's the x coordinate at 225? Negative root 2 over 2. And we've got some work to do. What's the coordinate at 90 degrees on the unit circle? So therefore, the tan is going to be 1 divided by 0. The y divided by the x, which is?
2.
Whoa. Look behind Jenna. Undefined. Friends don't let friends divide by 0. Do 1090 on your calculator. See what you end up with. You get an error, which means you can't do it. It's undefined. Right? We're just not making this stuff up. How about cosine 60? So again, do this if you need to. Just put x 60 degrees. What's the x coordinate at 60? At 60 degrees. When tan y divide x at 135. So what's the coordinate at 135? Root 2 over 2, comma, root 2 over 2. Negative root 2 over 2, comma, positive root 2 over 2. So we have to do the y divide the x. Root 2 over 2, divide negative root 2 over 2. Well, we don't have to change this to multiplication. What do you get when you divide something by its negative self? -1. And finally, sine y at 180. Yep. Done. Looks like you got to get familiar with our unit circle, which means starting tomorrow, I'm hammering you with unit circle questions. They will be, they're 20-mark quizzes. They'll be worth your entire year's mark. Okay?
Thank you.